Hello, this is Robert Miller, and I'm here to talk with you more about regression. And today what I want to do is I want to talk a bit here about the regression equation. And I want to take my time with you regarding the regression equation, talking with you about different parts of it, because for some people, for a lot of people, it can be a lot scarier than it actually is. Have a lot more bark to it than it really does have bite. And I also want to try to bring some of this down to earth for people in terms of what regression analysis is, or at least begin to do that during this discussion we're having right now. So let me just start to draw the regression equation up here. I promise you it's all going to be all right. Okay, we'll make it through this together. It's actually more straightforward than it might first appear. So first of all, let's start with the y variable. And the y variable represents a score on the outcome variable, and more specifically, the outcome variable measure. And we'll get more specific about this in terms of what we would call these different variables, but we'll keep it more general for right now. So y refers to the outcome variable and a score on the outcome variable measure. Now, when it's just the y, that is referring to the actual observed value on the outcome variable measure. So that's the value that you get on the outcome variable measure when you give that measure to someone and they fill the measure out, and then you as the researcher, let's say, later you score it, that's the actual observed value that a person got on the outcome variable measure. So that's the observed value, and when you're referring to the observed value, it's just y. But then when you dress up the y variable a bit, okay, so you dress it up and you put a hat on it. So now that's called y hat. Well, then you have a different value on the outcome variable measure that refers to the outcome variable measure, and that's the predicted value on the outcome variable measure as predicted by your model. And we'll talk about the model in a minute. But I just want you to note then that on the outcome variable measure, you actually have for each of your participants two values. And just tuck that away in your mind for the time being. I'm not going to spend much time on it during this particular presentation, but I want you to tuck it away in the back of your mind that again, you have two values for each of your participants in your sample on the outcome variable measure. You have the actual observed value on the outcome variable measure, the actual score that each participant got on the outcome variable measure after they filled it out, and it was scored by the researcher. And then you also have, when you put that hat on top of the y, so you have y hat, dress it up a little bit, so you have y hat, you have the predicted value on the outcome variable measure as predicted by the model, which we'll talk about next. Okay. So what we're going to do is we're going to talk about the regression equation as it concerns predicting a value or score for any particular participant in your sample from the model. And so here we're talking about y hat, or the predicted value in the outcome variable measure from the model. So y hat equals, and now we get to the model. So here's where the model begins, right after the equal sign. And it begins with a constant. And the constant can be understood as a value that adjusts the predicted value coming out of the model so that that predicted value will fall within the range of possible scores on the outcome variable measure. An adjustment needs to be made so that that occurs, and the constant provides that adjustment. So that's the constant, A, plus, and now what I want to do is I want to start to get into some different colors here because I want to emphasize different parts of the regression equation. So I'm going to go over here now and get another marker. And I'm going to put something down here called B sub 1. And we'll talk more about what that is in a minute. I don't want to get to it right now. I know that you are in suspense and you want to know what it is right now. But one thing that we do here is we kind of take things a step at a time. So we show some patience. Okay. And so while you're showing some patience, you can also show patience with me as I switch between markers here. Okay. So that B sub 1 is called a regression coefficient. And that regression coefficient concerns a particular predictor variable, which we're going to call predictor variable number 1. And that represents a particular variable that you have a measure for, and that you're going to be using the score on that predictor variable measure as part of predicting a value for each participant on the outcome variable measure. So y hat. Okay, now let's say, because we're talking about multiple regression here, which means we have more than one predictor variable in our model. So let's say that we have 3 predictor variables in this model. Okay, so we keep going here then. So plus. And at this point, it becomes rather repetitive, right? I mean, we get a certain pattern going on here. What you're seeing right here is basically what you're going to see as we continue down the regression equation, down the model. It'll just be for additional predictor variables. So here we have another regression coefficient, B sub 2, and this is the regression coefficient for our next predictor variable. Predictor variable number 2. So here we have predictor variable number 2. And this is a second variable that we have a predictor variable measure for that we'll get a score on from our particular participant. This whole regression equation, by the way, that we're looking at right now can be applied to each, and in fact is applied to each, of the participants in your sample. Okay, so from each participant in your sample, you will get a score. It'll be an observed value on the outcome variable measure. And you'll also get a score on our first predictor variable measure from this participant, and you'll also get a score on the second predictor variable measure from the same participant. Okay? And so this is our second predictor variable in the model, for which we will get a score on the predictor variable measure for this particular participant. And then, to finish our model up, because this model consists of 3 predictor variables, we now have our regression coefficient, sub 3, and that's the regression coefficient. No surprise, based on what you've seen already, for predictor variable 3. So this is our third predictor variable in the model, for which there is a predictor variable measure, and for a particular participant in the sample, we will also get a score on this predictor variable measure as well, just like we did for the same participant for the second predictor variable measure, the first predictor variable measure, and for that same participant a score on the outcome variable measure, which we call the observed score. That's the score the person actually got on the outcome variable measure. So this all applies for any particular participant in your sample. Okay. All right, so now let's take a deep breath here and let's look at this a little bit. Well, the first thing I want to ask you, because I really want to help bring this down to earth a little bit, okay? Because one of the things that happens in regression is that people talk a lot about high-minded concepts. And that's fine. I do the same thing in these discussions with you. But I want to bring it down to earth a bit because in talking about these high-minded ideas like homoskedasticity and heteroskedasticity and multicollinearity and all these fun ideas, okay, sometimes we can kind of get, I'm trying to think of the phrase, the trees mixed in from the forest or something like that. Okay, you know what I'm talking about. You kind of lose sight of the bigger picture. And you get too much into the details, and you really get away from just, really what is regression and what is it doing, what is it trying to accomplish. And we're going to get into that as we go along in further discussions. But right now, what I want you to get a sense of, in looking at this regression equation, and by the way, this is the regression equation, and this is the model right here. This is the model consisting of the constant and each of our predictor variables. So here's the equation. Whole thing, here's the equation. This part here is the model. Okay? And we're seeking to predict what a particular participant's score will be on the outcome variable measure. That's why we call this y hat from the model. Okay, so I got a question for you then. And that is, looking at this model, actually, it's a little bit broader than that. Looking at the equation, looking at the regression equation, okay, which goes all the way from here, we have y hat, all the way through the model. So this whole thing here is the regression equation. Looking at the regression equation, can you tell me that when you're collecting data for your regression analysis, how many measures you're going to give each of the participants that are going to be in your sample? Let's say that you had 100 participants in your sample, so you had 100 people in the room, and you were going to give to each of those people a stack of measures to complete. And then you take the data, the scores from those measures, and then you put them into some statistical analysis package and you analyze it for your regression analysis. My question for you is how many measures are in that stack of measures that you give to each of the participants in your sample, to each of the persons that are in the room, each of the 100 persons that are in the room, how many measures are in that stack of measures that you're going to give to each of the participants to fill out? So look here at the regression equation, and how many measures are going to be in that stack of measures that goes to each of the participants in your sample, each of those 100 people in the room. Da 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 da. See, for those, well, of course, the show's still on now. You should recognize that as the Jeopardy melody. Da 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 da. Now the difference here is you don't need to answer with a question. Da 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 da. Ding! Here's the answer. Okay. Well, let's see. There are going to be, in that stack of measures that you give to each of your participants in your sample, there are going to be 1, because you need a measure of your outcome variable, right? They need to fill out that measure. 2, you need a measure of your predictor variable, number 1. You have to fill out that measure and get a score on that. 3, you're going to need a measure for predictor variable, this predictor variable in your model, Your participants are going to need to fill out that measure and get a score on that. And then 4, you're going to need a measure for this predictive variable as well in your model. And the participant will need to fill out that measure and get a score on that too. So you're going to have 4 measures in each stack of measures that you give to each of your participants in your sample. There'll be 4 measures in that stack. 1, 2, 3, 4. And so I'm going to conclude this discussion. We'll have more by just pointing out then what you're doing, right, with this regression equation, is that you are predicting each participant's score on the outcome variable measure from their scores on the predictor variable measures. Okay? So you are seeing how well can you account for or explain variance on the outcome variable measure in terms of person scores on the predictor variable measures. Okay? And that's essentially what you're seeking to do here. And so we're going to talk more about that later in further discussions, but that is the beginning part of things regarding the regression equation and the regression model for now. You have a good day.